In this video, we'll write the balanced net ionic equation for CaCl2 plus ZnSO4. This is calcium chloride. This is zinc sulfate. So the first thing we do with these net ionic equations, we have to balance the molecular equation. This is the molecular equation. It looks like it's already balanced, so that's kind of nice. Now we can write the state for each substance, and that looks like this. Compounds with the chloride ion in general, they're soluble, and in general, compounds with the sulfate ion are soluble with a few exceptions. One of those exceptions is calcium sulfate. Calcium sulfate is insoluble or only a very small amount dissolves. So we consider this to be a solid. When these two substances react, it'll form a precipitate that will fall to the bottom of the test tube. So these are the states. Once we have the states, we can split the strong electrolytes into their ions. That'll give us the complete ionic equation. Note that we don't split solids apart in net ionic equations. So when we split the strong electrolytes, this is what we'll get. So this is the complete ionic equation. Now we can cross out those spectator ions that are on both sides of the complete ionic equation. So I can see in the reactants here, I have 2 chloride ions. In the products, I also have 2 chloride ions. These are spectator ions. Cross those out. I have the zinc ion here, and again in the products, spectator ions. We cross that out. But what's left, that's the net ionic equation for CaCl2 plus ZnSO4. I'll clean this up, write the states. We'll have our net ionic equation. So this is the balanced net ionic equation for calcium chloride plus zinc sulfate. You note that charge is conserved. We have a 2 plus here and a 2 minus. So this all adds up to 0. Net charge of 0 over here. It's neutral, so net charge of 0. Charge is conserved, and if you count the atoms up, they're balanced as well. This is Dr. B with the balanced net ionic equation for CaCl2 plus ZnSO4. Thanks for watching.